All right, everybody good? Okay, so the next thing that we talk about is if we're going to have something like this. So again, we're talking about trigonometry, so it has to be a right triangle, right? And we talked about, I don't know if we talked about this in your class. Did we talk about that symbol in your class?
No.
So this symbol, anybody know what this symbol is? Anybody have a brother or sister in a frat or sorority?
Yeah, I used to.
This is theta, okay? This is just a Greek letter. So instead of saying to find a specific angle, so instead of saying that this is A, B, and C, sometimes they just use a symbol like that. So they would say find theta, okay? Well, in this case right here, theta is a what? An angle, right? So from here then, they might give you two numbers. And sorry if this doesn't work in your calculator because I'm just making it up. But let's just say that this is 4 and this is 7. Okay? So the difference between this problem right here is, in this particular case, we are looking for a what?
Angle.
Looking for an angle. In the last problem that we just practiced punching into a calculator, we would have been looking for a side. Okay? When you're looking for a side, you can use the normal trig functions. Sine, cosine, and tangent. Now everybody look at your calculator again. And do you see the things right above it? Probably your second key, where it says what?
Inverse cosine.
Yeah, it says this, right? It says sine, and then it has a little -1.
Yeah.
The cosine, and the tangent. Okay, so you can either say that these are the inverse sine or inverses of each, or you can say it as the arc sine and arc cosine and so forth. So that little -1 says arc in a sense. You are anytime that you, from here on out, are looking for an angle, you know in the back of your mind that you're going to end up using the trig ratio, but with the little -1. Okay? So that's what you got to click in your head. If I'm going to find a side, I can use the regular one. If I'm going to find an angle, I'm going to use the -1s. Okay, so in this problem right here, from theta, what relationship does theta have to the two sides that are given? Tangent. So we're going to write tangent, and what did we say always has to go with the word yesterday?
Angle.
The angle. So now, we don't know what that angle is, so I'm going to say the tangent of theta is equal to, and then my number is what? What's my fraction? 4/7. Everybody good with that? Why it's 4/7? Because from theta, it's opposite over adjacent, right? That's what we talked about yesterday. Okay? So why does this happen? Well, basically it's saying, well, how do I get theta all by itself? Okay, so in a sense, you're dividing by tangent, and when you do that, theta then becomes by itself. But when you take regular tangent to the other side by dividing, that's when you get tangent of -1. Because really, the tangent of -1 says that I'm kind of taking it divided by, or 1 divided by whatever my answer is. And that's what -1 means. So this is just a different version of it and how you would write it. So now, you can do this one in 2 different ways. You can put parentheses around here and just punch all of that into your calculator. Second tan, and your first parentheses should come up, and then just hit 4 divided by 7, and close out your parentheses. Or however you do a fraction. Or you can punch this in first, punch 4 divided by 7 and get a decimal, and then just hit second tangent to that answer. And what you come up with. I honestly don't know if it works. Okay, so it works. Now, here's the other thing. Does everybody know that you have an answer key on your calculator?
Yeah.
Okay? Mine is at the second function of my negative sign. So look on your calculator and see if you have a button that says ANS. That means answer. So when you have a decimal, so like in this case right here, if everybody punches in 4 divided by 7, you get a decimal, right? And we've told you, if you want to be precise, that you should never round that decimal until the very end. So you should use that whole decimal in your problem. So if I'm going to do it this way, where I punch in my fraction first, then I would hit second tangent, and instead of trying to type out all of those decimals, you just hit second answer, and that answer goes back in there, and you get your 29.7. Okay? So your answer key is just putting your answer from the previous problem into that next thing. So you don't have to copy down all those decimal points. Okay? So that's where, instead of, a lot of you would say, well, I'm going to use decimals, but you would round it. So you would look at this one and you would have maybe only used 0.6. Well, instead of that, now we can use the whole number by using that answer key. That makes sense? Pretty cool button, right?
When you see tangent and then sine equals 4/7, can you just do it in your head that it's going to be tangent minus 1? And then just.
Can I do it in my head that what?
Do I have to-
Yes, absolutely. I'm just showing you why this actually happens. So yes, as soon as you know that you're looking for an angle, you know that you're going to use this button instead of regular tangent.
Would your like 29.74 be the angle?
Would be the degree angle, exactly right. So if this angle then is 29, and here you can round to one decimal place, so we'd get what?
0.7.
0.7 degrees. Now, how do I find angle A?
Subtract
Just subtract it from what?
90.
From 90. Why am I doing it just from 90? Because these two have to add up to 90 degrees. Make sense? Okay? Well, we'll get to that in here in just a second when they ask us to actually solve. Okay? So anytime that they ask me to find an angle, I'm going to use the buttons that have -1. So another example of this is, so sometimes they might already give you the decimal. So if they say the cosine of b, it's just like saying the tangent of theta, right? Theta is an angle, b is an angle. How do I know b is an angle? Because it's a capital letter. Okay, so cosine of b of 0.798. So they already gave you the decimal, so basically they divided their fraction, and they got that decimal. We don't know what the fraction was. So, what do you get? Second cosine of, so b
37.
equals cosine -1 of 0.798. And you got what?
37.1.
37.1. And then don't forget that it's degrees, right? Because it's an angle.
How come when I hit second cosine here, it does that?
Yours is those up there. So you gotta hit.
I need to scroll. I need to scroll.
You gotta hit it twice.
Okay.
So if you're using one of these from up here to get those buttons, you'd hit that sign twice. You don't have to hit shift. You hit sign twice, or cosine twice, or tangent twice. And then on your phones, I think it's a whole nother button.
There's like arrows for mine that it just
Yeah.
switches over.
Alright.
I just hit second.
Yeah, no, yours
Second.
Like I said, I have like arrows that switches over.
Depends on
Alright.
what phone you have.
Let's see. What else we gotta do?
So long. Just.
So then the last thing that they're going to ask us to do is simply just to solve the triangle. To me, when they say solve the triangle, you are trying to find every single thing that you possibly can. You don't have to necessarily say the 90-degree angle, but you're going to try to find everything else. So, let me show you one of these. So we could have something like this. Stop the right triangle again. 4, 7, ABC. So when you are asked to solve, you can use any math that you possibly can think of. So obviously here, the easiest way for me to find little c or AB is what?
Oh,
Pythagorean.
Pythagorean theorem, right? So what's 16 plus 49?
65.
65. Can I reduce 65?
No.
I don't think so. So we'd say the square root of 65, right? So now, how do I find my other two angles? Or how do I find my angles, right? So first things first, you just got to decide. Which one am I going to find, A or B?
Just do it.
A. Somebody said A. So I'm going to find A right here. So again, this is my personal preference. What I would urge you to do, because you found this number, you don't know for sure that it's right. You would hope that you did it right, because that's you solving the problem, right? But just in case that you messed up with your math, and it was actually the square root of 66 instead of 65, then in this case, when I'm trying to find A or B in this case, I'm going to go back to the numbers that they gave me in the problem. Does that make sense what I'm saying? If the book gives me numbers, I'm going to use the book's numbers all the time. So, here's the question. From A, what relationship do 4 and 7 have with A? Tangent. So we would say the tangent of A, right, is equal to what? 4 over 7. Did we
It's
just do
right
that
there.
one?
Yeah.
Whoa, weird. So, what was my answer? 29.7. So what's B?
61.3.
61.3. And again, this is where you would read the directions to see what you would actually get.
You'd always,
60.3.
60.3.
but you'd always put, depending on the relationship that you used.
Say it one more time.
So like, I know you have the square root of 65, but we don't know that's right, so you use tangent because you know that those numbers are right.
Because I know 4 and 7 have to be right because the book gave it to me. Or on the quiz or the test, those are the numbers that I gave you.
Well, let's say that 65 was right, you could use cosine. you could use-
Absolutely. If you're confident that your square root of 65 is right, then I can do sine, and then I would do 4 over the square root of 65.
Which is more.
But I'm just making sure of it, in a sense.
Isn't that just the same thing?
It would be the same answer. You're going to get the same answer whichever way you go. I'm just making sure. I know that 4 and 7 have to be right because the book gave it to me.
You don't know the square root.
Okay?
It's a tangent because it's adjacent.
Opposite over adjacent. Yes. Okay? So, all of that is the whole thing. So let's go back and then review what we did yesterday then. So, how are we going to remember our 3 trig functions? SOHCAHTOA. The most important part of SOHCAHTOA?
Spelling it.
Spelling it. If you don't know how to spell it, you're kind of, you know what? Go ahead, you can turn this way now.
I won't be able to see if it's on that or not.
Alright, so, here we go. Express sine, so I want you to find sine, cosine, and tangent from L as a fraction and as a decimal. Okay? Find sine, cosine, and tangent of L as a fraction and as a decimal. Remember now, when you have a fraction, you want to make sure that you try to reduce it as much as possible. So again, anytime going forward when you get into trig, if it's on a quiz or a test, ISAS, ACTs, I write SOHCAHTOA on the top of my paper, right? We just got to remember that we want to make sure that it's spelled right. And again, the capital letters in SOHCAHTOA tell us the 3 trig ratios. The little letters tell us the sides that we're going to use. Remember now, when I'm asked to find the decimal in this section, I don't use what?
Sine, cosine.
I don't use the buttons on my calculator. I might have to use my calculator, but I don't use sine, cosine, and tangent.
You just divide the fraction.
So the most important thing is remembering or following the directions. So what's the sine of L?
12 over 37.
12 over 37 for my decimal.
0.32.
Okay? Cosine of L.
35 over 37.
35 over 37, so we get 0.95 and tangent. 12 over 35, which is 0.34. Questions?
I did not get that out.
Oh!
I wasn't doing negatives.
You should have done the negatives anyway.
Wait, what?
You take.
You're not doing the negatives. What are you talking about?
Don't use sine and cosine. Don't use.
Do not use sine and cosine.
Or tangent. You just
Do
divide
the
it.
fraction and then just divide them.
Gabe, you just divided 12 by 37.
Just take 12 and divide it by
You're
37.
not using your calculator.
It's a 35 over 37.
Then we need another example of that guy.
Silly. Gabe,
So, to find those sine, cosine, and
Well,
tangent.
because you need that. We're looking at sine though.
You do not use the words.
Only when it says like
So,
cosine or
then you use first.
Oh, so you change cosine to fraction.
No, no. You're using it or you're not?
Use it if there's a number with,
Yeah, we'll come back and talk after we're done. Okay? Hold that thought. Here's the problem right here. Fitness trainer sets the incline on a treadmill to 7 degrees. The walking surface is 5 feet long. Approximately how many inches did the trainer raise the end of the treadmill from the floor? So how do I find y? What relationship do the angle that they give me and then those two sides have? The sine, right? The sine of what? What always goes with the word? The degrees, right? So my answer is going to be sine
7 degrees.
of 7 is equal to y over 5, right? Sine is what? Opposite over hypotenuse. So again now, this one we didn't talk about. It's a little different than how we got to this right here. This one right here, all we're doing to find y is what? Multiply sine of 7 by 5. This is where you got to be careful though, okay? When you punch this one into your calculator, if you punch sine of 7 first, you got to make sure you close out your parentheses. If you put 5 in first, you shouldn't have to close out your parentheses at the end. Does that make sense what I'm saying there? So, if you punch this in and you take 5 times the sine of 7, what do you get for y? 0.6 what?
1.
What? Feet. Right? 0.61 feet.
Oh, that makes sense.
Did everybody get that?
Yes.
Do we do the minus?
Gabriel, are we looking for an angle? Gabriel, are we looking for an angle? No. Then you don't use the negative. So, you should punch that in right there, bud.
0.61
5
times.
times the sine of 7 equals. What do you get?
0.61.
There you go. That's the answer. You understand?
Yes.
Be patient.
That kind of confused me a little bit.
We know. It confused all of us.
You be patient with him.
So this one you got to think for a second. The bottom of a handicap ramp is 15 feet from the entrance of the building. If the angle of the ramp is about 4.8 degrees, about how high does the ramp rise off the ground? Are we finding the right-hand side or the incline side?
right hand.
The right-hand side. So what relationship does the angle have with the right-hand side and 15?
Tangent.
Tangent. So that's where we would use tangent. Everybody good with that?
Yeah.
So what are you going to punch in your calculator, Gabriel?
15 times tangent of 4.8.
Thank you very much. And what do you get?
1.26.
15 inches. 15 inches.
Oh, I forgot to put the times.
So here's the big thing right here, right? You got 1.2. What did you say?
Yeah, I put it.
So why is 1.2 the same thing as 15 inches? What does their 1.2 really mean? It's 1 foot plus another, what? Right? So notice, the original problem had it in feet. The answers they gave you are in inches. So their 1.26 or whatever you got is in feet. So you got to convert that into inches. That makes sense?
What?
So it's 15.12. So you got to make sure that you look at the labels in the problem. Make sense? Are you good with that one, Gabriel?
There's 12 inches.
Yeah, that one confused me a little bit.
I know, everything's confusing you right now. Use a calculator to find the measure of angle P. If I'm looking for an angle, Gabriel, you're going to use what?
Negative.
The negatives. Okay, so from P, what relationship do 13 and 19 have?
Cosine.
Cosine. So I'm going to do what?
Cosine negative 1 times,
Not times.
or, oh yeah, cosine.
So you're going to do cosine negative 1 of, what's my fraction? 13 divided by 19. Or I punch 13 divided by 19 in my calculator and then hit second cosine.
46.8.
How much?
46.83 degrees.
Everybody else agree? So if we carry this one on a little further, 46 what?
0.83.
8.3, so we'll say 8. Don't forget to put a little degree symbol there. Okay, so what's Q? What's angle Q? Now if you want to practice like Gabriel, then you would say what?
43.2.
Then I would say second sine of 13 over 19, if you wanted to practice. Or I can just simply what? Subtract it. Okay? What is little p?
Can you just do the negative term and then
So what's little p? How much?
23.02172887.
I got 13.8.
Total 91,200.
How?
13.8.
Square root of
I got
530.
13.9 actually.
You should have taken the square root of 192.
Oh,
yeah.
it's 13.8.
Oh, yeah, I did that as A, not C. I can't do problems fast. I have to look at them.
What'd you get?
13.8564. You might actually give me a heart attack on this one. You might give me one. Yes, you might give me
You might give yourself one, dude.
Alright, so solve the triangle. Solve the triangle. Again, the easiest thing to find is probably my hypotenuse, right?
Yeah.
So what's 121 plus 64? 185. Can I break 185 down? They obviously used a decimal. Again, I would not use a decimal, but that's fine. So what's the square root of 185? How much?
13.6.
13.6. So, again, if this is ISAFs or ACTs, what are we doing?
Eliminating.
We're eliminating stuff, right? Automatically, we know that those two can't be right. Everybody understand why? Everybody good with that? So again, this is why I don't like multiple choice problems for math, because you really don't even have to know the answer and you got a 50% chance. As long as you can do something easy like Pythagorean theorem. Okay, so how are we going to find A or B?
For A, you could do
Alright, so Brandon said A. So if we're going to do A, what are we going to use? Tangent or second tangent of what? 11 divided by 8.
so it's inverse of it?
Inverse tangent of 11 over 8. What do you get?
Angle A is 54 and angle B is 36.
So which one do we got? What's my answer then? Huh? B? So again, this is one right here. See where they say angle measures to the nearest degree? I don't like that because it could really be distorted. You know, you really realistically think about something being 0.6 or 0.4, and that goes back to something else. That's a lot of difference. You know what I'm saying? Okay. So again, make sure you read the directions, especially on the quiz and the test. Okay. Okay? Questions? A lot of information in this section, there really was, right? Okay? But it all kind of ties together. That's why we took a couple days. Make sure you read the directions.
All this is massive stuff.
This one will be quite big. Don't freak out about the points because the first one's obviously worth 12.
What?
Because you gotta do sine, cosine, and tangent, and you gotta do it in
I need like 5 pieces of paper.
There we go. Everybody's still.
Sheila, did you stop it?
It's a little small though.